Hi everybody. So this is one of our first videos. We're going to be looking at solving linear equations. This problem is an example which is going to incorporate a lot of the steps that we are going to be looking at when we're attacking these types of problems. So the first thing we're going to do on either side of the equation is we are going to distribute the number that's outside of the parentheses. So we're going to multiply that 6 times x and times -1. And on the right side, we're going to distribute that 3 times 7x and distribute that 3 times the 1. Now, once we have distributed, we are then going to combine like terms where we can. So just working on one side of the equation, I'm going to be looking at the left side. I'm going to combine the -6 and the 4. So that's going to give me -2. And on the right side, I'm going to combine the 3. Oh, excuse me, I left out an x. So let me back up a little bit. I'm going to combine the 21x and the -5x, which is going to give me 16x, since those are like terms. Okay, so notice how we just worked on the left side of the equation and then we worked on the right side of the equation. And I'm going to call that CLT, combining like terms. So now, on either side of the equation, I only have an x term and I have a constant term, meaning a term without an x. So now I'm going to try to get all of my x terms to one side of the equation using opposite operations. So since I have more x's on the right side, I am going to get rid of the x's on the left side by subtracting 6x. So 6x minus 6x is no x on the left side. And to keep this equation balanced, I'm going to have to subtract 6x on the right side. Now, I'm going to get my x term alone, so I'm trying to get 10x alone. So I need to remove the 3 on the right side. And again, to keep the equation balanced, I need to subtract 3 on the left side. So now my x term is alone on the right side. But now the final step is to get just my 1x alone, again using opposite operations. So we have 10 times x is -5. I want to know what just 1x is, so I'm going to divide the right side by 10. And again, whatever I do on the right side, I'm going to have to do on the left side to keep my equation balanced. And this gives me -5 divided by 10, which I can simplify to -1/2. And we are finished with this particular problem. Okay, before I put an end to this video, I do want to bring up the idea of checking the solution that we just found. So we found x to be -1/2. What I'm going to do is I'm going to take that -1/2 and I'm going to substitute it into the original equation everywhere that I see an x. So let me just write the original equation again. So everywhere I see an x, I am going to substitute -1/2. And for simplicity's sake, let's call this -0.5. Okay, because I don't want to get bogged down by the fractions right now. So everywhere I see an x, I'm going to substitute -0.5. And I'm going to put it in parentheses in places where there should be multiplication. So let's start to do some of this math. So I'm going to follow the order of operations and work on the left side separately than working on the right side. So let me simplify everything on the left side first. So in parentheses, -0.5 minus 1. So that's -1.5 plus 4. 6 times -1.5. Well, we could do the math there. That's going to be -9 plus 4. And then finally, I can add those two together and get -5. So now, if we found the right solution, when I do all the arithmetic on the right side of the equation, I should get negative 5 also. So let's see if that's true. So 7 times negative a half, so that's negative 3.5 plus 1. And over here to the right, I'm going to multiply negative 5 times negative 0.5, so that ends up being positive 2.5. And again, I'm following the order of operations, so I'm going to continue to work in these parentheses. So negative 3.5 plus 1 is negative 2.5. 3 times negative 2.5 is negative 7.5 plus 2.5. And finally, negative 7.5 plus 2.5 is negative 5. And you can see that the left side is equal to the right side. So our solution of x equals negative a half is true. That is a correct solution. And before we go, I want to reiterate, checking your solution after you've solved an equation is a really good idea to ensure that you got the correct answer. If we had done this check and say we got negative 7 on the left is equal to negative 5 on the right, that would tell us that we made a mistake solving the equation above. So hopefully this helps.